The topic that I would like to present. Actually, I just try to use the automatic virtual metrology. This technology and the advanced manufacturing cloud of things and for weird machining automation. So to begin with, I need to explain what is virtual metrology. And virtual metrology is a method to conjecture manufacturing quality of a process based on data sensed from the process tools without physical without real physical metrologies. So actually, VM can turn the offline machining, I should say the offline sampling inspection with metrology delay into online and real-time total inspection. This technology was actually, the requirement was requested about 10 years ago by semiconductor industry. And actually, I have already invent the AVM system to accomplish all of the VM requirements and has been applied this to, for example, the semiconductor, TFT, LCD, and solar cell industry 10 years ago. But started from about 5 years ago, I switched the gears and tried to apply this AVM system to the traditional machine tools industry. And besides that, I still use the Internet of Things, big data analytics, cloud computing, and cyber physical system. And together with the AVM to develop the advanced manufacturing cloud of things. And there I'll show you, of course, this is what I call it's Industry 4.1, not just 0, because we emphasize not only increase the productivity, but also the quality. And I will show this later. And so this study used the weird machining automation as an example to illustrate the functions and operations of AVM and AMCOT. So what is the virtual metrology? So from this picture, we can show that VM is a method to conjecture manufacturing quality of a process tool based on data sensed from the process tools and without physical metrology operation. Why I say so? So you see, when we have a machine tools and try to machine a workpiece, then after finishing the machining, and if we would like to know the quality of this workpiece, so conventionally, we need to ship this to the off-machine metrology equipment, for example, the CMM equipment, to try to measure it. But you see, this kind of measurement is very time tedious. It takes a lot of time. So conventionally, we just can only use sampling inspection. So not only sampling inspection, but also has metrology delay. Because after finishing this machining, you need to ship it to the measurement equipment. And of course, the measurement still takes time. The real measurement operation still takes time. So this is what we call, is some kind of sampling inspection with metrology delay. So this is not desirable. What we really would like to do is if we can install the key sensors, for example, the accelerometer and current sensor and temperature sensor, etc. And of course, we use the ICT technology or use IoT technology. We can collect all of these kind of sensor data in real time so that we can collect all of them. And we call it, this is the cost-effect relationship, that is the cost. But after finish the machining, of course, we have this kind of sampling pieces, right? So these sampling pieces, of course, we can find out using this off-machine metrology equipment to find out the quality of that. In other words, under what kind of conditions, what kind of manufacturing conditions or operations that you can get this quality. So we can have this cause and effect relationship as a sampling, as a sample. So this is kind of modeling sample. So we can collect them something like 20 or 30 samples, and we just collect them into a computer. Then we can use a prediction algorithm, something like neural networks or multi-regression, and to train this model. Then after training, then we can have this kind of a virtual metrology model, and we put it into the computer. Then if during the normal operation, normal machining, after finishing the machining, then of course we can collect all of the sensor data in real time. Then after finishing collecting it, then we just send the data the input data to the VM models that is in the computer, then he can predict the quality value for you in about real time, maybe just in 5 or 6 seconds. So in other words, after finish processing, you can get the quality data about almost immediately. So you see, so this virtual metrology technology can turn offline sampling inspection with metrology delay into online and real-time total inspection. Allow me to show you the AVM system. So actually, I have this kind of demo 4 years ago, almost 5. Actually, we have this kind of demo in, for example, the TSMC and the UMC, etc. But for semiconductor industry, they won't allow me to take a picture or even the video of that. But the CNC machine industry, they allow me to do so. So about 4 or 5 years ago, I showed this one in 2012 Taiwan International Machine Tool Exhibition in Taichung and both in Taipei also. So what I really would like to show is the concept of AVM. And you see, this red dot is the real metrology. And the black curve is the virtual metrology. And the workpiece is iPhone 4 back planes. And what we try to measure is the maximum distance of the camera hole. So you see, after manufacturing, and we try to find the quality of that within 10 seconds. So let me show you what's going on. So you see, so it starts machining. Okay, finishing machining, then we count 1, 2, 3, 4, 5, 6. You see, about 6 seconds. He can give you a new prediction value there. So that is the value of the quality value that after machining. So you don't need to really move it to the CMM machine to measure it. You just can get it in real time. So this is the concept of the virtual metrology. Actually, this is the very first demonstration around the world, how to demo the concept, how to demo the virtual metrology technology here. Okay, so what is the AVM technology? Let me show you the traditional VM scheme. What I mentioned to you that we need to have a process data. And of course, in semiconductor manufacturing, then they have the production equipment. They have all kinds of sensors, and they already collect all those data in a database. Then we can collect all those sensor data from the database easily. But for CNC machine, most of the CNC machine doesn't install the sensors yet. But of course, we can install it by ourselves. So we have cooperation with FEMCO. And right now, their product always has all the necessary sensors in it, embedded in it. So we can collect the sensor data from the equipment. Then using this process data, and then if we have virtual metrology models here, then we can get the production. I should say we can get the prediction easily. But you see, we still need this kind of metrology data. That is the sampling output, because this sampling data only for training and tuning, because we still need, because the equipment itself is time-varying system. You need to know the status of your equipment. So we still need to have some kind of sampling metrology. I should say the sampling metrology data for tuning and training. But you see, this is the basic requirement. But anyhow, this kind of algorithm was requested, brought up about 10 years ago, but no one can really use it. Why? Because the first we have first problem because this is some kind of prediction. But you see, because they don't give you any kind of reliability index, so you don't know how good it is. So they are hesitating to use it. And then the second question is, you see, as well as we have already tell you that what we try to have virtual metrology in, we need to consider about the promptness and the accuracy. But promptness, you see, after we collect all the process data, we can conjecture it within about 10 seconds. But you see, after, because the equipment itself is time-varying system, if the equipment state has been changed, you need to refresh the model. So this kind of accuracy, we need to take care of them also. So those two things just conflict with each other, and we need to take care of promptness and accuracy simultaneously. And this is another big problem too. And the others, you see, traditional VM scheme, you see, when we do this kind of data mining or data big data analysis, then the data quality itself is very important. But traditionally, they didn't know how to do the data quality check in real time. So that is another big issue that we need to take care of. So what I propose to do is, this is the algorithm that I invent. So you see, to begin with, then we have generated a company reliance index and global simulated index, so that not only provide the virtual metrology value, but also the reliance index. So you know how good it is. So users can use it. They have confidence that how good it is, so they can use it. And the second one, we have a dual phase algorithm. And this, so the promptness and accuracy can both be taken care of. And the phase one emphasizes promptness, and phase two improve the accuracy. And the last one is the data quality evaluation. So the AVM system can evaluate the quality of the process and metrology data online and in real time. So that's the output of the VM value can be further assured. So you see, and not only those features, but also you see, we can check here. So this red dot is the actual metrology. And we have two prediction algorithm. The black curve is the neural networks, and the blue one is PLS. And you see, if those two are about the same, you see, so we have confidence of all the results. But you see, for this point, what I told you, the reliance index, we just check that there is an abnormality detected online. Then alarm can be sent too. So this is one of the advantages of AVM, in addition to total inspection. In other words, when the system is smooth, when the system, the machine itself is very stable, then the accuracy is about the same as what you really use the real metrology to do it. But when the machine itself has something wrong there, then you see, we still can detect it. You see, this is, the prediction of this one actually is no good. Don't use it. Actually, this is the real situation of what I demo in the picture. And why we have this kind of situation? Because the iPhone 4, when you just clamp it, when you use a fixture to fix it for machining, but at the time, the fixture is not very fixed. There's something wrong there, so the vibration signal is different. So they can detect this kind of signal and to see, you see, this prediction is no good. Actually, when we really go to real metrology, and you see, actually, we have difference there. So this is one of the features that AVM system have. So we give you the example of for FEMCO and FATEC. What I show you here, actually, you can see the real demo this afternoon. You can go to the booth of that at 3:30. You will see the everything. But I just try to present what we will show in the afternoon here. Okay, so for this turnkey solution, this wheel machining automation, we have 2 days lattice and one drill machines. And you see, conventionally, when we have a wheel, and of course, just bring it to the lathe and for machining one side of that. Then, because the central hole diameter is a critical dimension, so we need to have total inspection of that. And then we will machine the other side, and then try to drill the holes, or something like that, okay? Then after that, then, of course, we finish it and you just finish the operation. But you see, we have so many quality items need to be inspected. But here, they just can only measure the central hole. Because if you would like to know all of the quality of that, you need to ship this one to a CNM machine for measurement. And of course, that is something like offline. And we have a metrology delay. And we just can do sampling inspection only, not a total inspection. If we really would like to have total inspection of all of them in real time, then how can we do it? So this is the way to do it. You see, we need to install the sensors, such as accelerometer, current sensor, etc. And then we will collect all of the data through an IoT device called GED. Then this data will be fit into the AVM system, and he can conjecture all of the quality values in real time. And I'll show you later. But you see, for Industry 4.0, in order to have this kind of system works, we need to have working process, I should say, with tracking also. So we need to have a laser marker and to grab an ID or QR code on the wheel. And we have a reader to read the ID also. And you see, the measurement equipment, of course, we still need this kind of measurement value, sampling values, and for tuning the model. So you see, for block diagram, you see, this is the machine itself. So we will install the sensors and in that. And of course, we still collect the necessary data from the controller also. And you see, this is the data collection device. Actually, this is one kind of IoT device. And they will collect not only the process data, but also the metrology data, and then feed it into the AVM server. Okay, so you see, this film was taken 2 years ago in Jiayi, and but anyhow, the whole machine, the whole set, whole turnkey has been shipped into Nangang. So you can see all the operations in the afternoon, and you see we have OP1. That is this machine. OP3, I will demo those two, and that is the drill machine. And we have a Fanuc robot, and we will show you the VM result. So this is the GED client. And you see, we need to do with tracking. So you see, we have, for example, this number 7, 8, 9, 10, etc. So see, then we will show you. Okay, no sound. I need sound. Oh yeah, okay. So you see, so because they need to clean it. So after cleaning, then he will put number 11 into the machine, the OP1. Okay, so when you put OP1 in it, when he close the door, the drill machine start operating. And you see, okay, so it's start operation. And you see, this try to collect all the data, okay? But after finish the first operation, then he need to use the laser marker to mark it, okay? So you see, so that we have a laser ID there. But when we will show you that after finish the machining here, actually we have 3 quality items shown here. Okay, we have central hole, outer diameter and flatness, etc. After finish this one, we will show you that he will predict the output of, would you please turn the volume a little bit down? Okay, so, and not only the OP1, but also OP3 and OP2 too. And because we have ID already, so before entering the machine, we need to identify which wire has been shipped to the machine, to the CNC tools for machining. So you see, be careful here. It's about done. After finish this one, we can predict the value here. So okay. Yeah, count 1, 2, 3. Okay. So we have predict the value, and you see, then the door are open. So even the door haven't completely open, the quality has been conjectured, has been predicted. So just by the same token, not only OP1, but also OP2 and OP3, after finishing it, then we can predict the quality about in real time. So you see, all of them, after finish all of the operations, he can get all the quality data. And all those quality data, you can correlate them together and convert it into QR code. And we can use the laser marker and to engrave all of the QR code on the wheel. So you see, this is one of the requirements of Industry 4.0, because on the product you see this one, show you here, you see outer diameter, flatness, etc. Those quality values can be engraved on the wheel itself. So you see, each wheel has its own quality value on it. So if you really would like to know the quality of that, you just use the laser reader to scan it, and you know how good it is. So you see, so this is what we call you. This is actually a miniature of Industry 4.0 realization. And not only Industry 4.0, I will give you the concept of Industry 4.1, because Germany invent or propose the Industry 4.0. But what they really would like to promote, they just emphasize how to increase productivity. So that is very good. But you see, they didn't say how to do, how to enhance, how to increase the quality. Why? Just because they don't say how, they don't know how to do total inspection. Because if you really would like to increase the quality, you need to do total inspection in order to have zero defect. But they didn't define how to do it in Industry 4.0. So that is the key that I propose to have Industry 4.1, because I can use AVM system, include AVM system into Industry 4.0 to become Industry 4.1, and we can achieve the goal of zero defect. Then I'll come to that later. So you see, this will be the result. So then the cyber-physical system, the AMCOT, okay. And you see, what we really would like to do is try to let these GED functions to make it as an IoT component. So you see, actually we have a patent of that also. It have Taiwan, US, and Japan patents, because our IoT device should have smart application. Then how to do the smart application? This is a pluggable application. You can just repress this, something like APP, just download APP, just plug in, and you can have various kind of applications you want. For example, you can have predictive maintenance modules, etc. So you see, this is the proposal that we prepared for FEMCO. This is the vendor, okay? And those are the customer, and we have private cloud there. So you see, the system, you see, here, this is the vendor, this is one of the customer. So you see, the AVM system, we can move the AVM into the cloud. So you see, because after finish the modeling here, we know we can install or we can upload the models in the cloud. And then the customer just pay by use, of course, because those turnkey or all those machines was provided by the vendor. And so the vendor knows what kind of type they have. And they can download the VM models from the cloud. And after download it, and they can use these models to do contextually. Now I'll show you this later. So you see, as I said that, you see, AVM server originally is just besides the production line, but we can move them to the cloud. Actually, this one has been, actually, I have already got this kind of technology and used in semiconductor industry. The same technology can be used for machinery industry also. So the application example, AMCOT, actually what we have industry and university cooperation project with the FEMCO and the FATEC. And you see, when we have this kind of technology used in semiconductor, I should say in machinery industry, then we really have demoed it on April 2015. At that time, one of FATEC's customer to see the demo that I just show you the video, and they just impressed, and they invite us to mainland China to install, to test that the system is good for mass production or not. So you see, we just try to prove that all VM models constructed in Jiayi, Tainan, can also be reused to the same type of tools on the production line in China. Okay, and just use 1 to 3 samples, and that we can use it. And we can use the same model in mainland China. And you see, we have 3 periods for testing. So the very first one, just check that the model built in Taiwan can be reused in China also. The second one, we try to convert, I should say, we try to combine the consoles. I'll show you later that because we will have we are processing console and AVM console, but we need to combine them together within just single console. That is easier for manufacturing and for shop floor control. And the second one, we need to do, we need to finish, meet the requirements of mass customization. In other words, we need to cope with different wheel types. So I'll show you how to do it. So you see the experiment. Let me show you. So the very first period, they have 2 lines to combine together, and this is drill machine and less machine. And you see, originally they have a wheel process console here, but the AVM console is just separate. We just proved that the AVM technology can be used in. That is the very first period. So of course, that is a success. And the second phase, we will merge these console into that one. Okay? So actually, after 3 period testing, and the quality of that, you see, according to the accuracy table shown here, under the condition of stable automatic wheel processing, the average contextual error is just within 0.01 millimeter. So the customer is very satisfied. They like this very much. In other words, the quality of the measurement of virtual metrology is about the same as physical measurement. Okay. And then the second, so let me show you this one, because this is what we call in the cyber-physical interaction. AVM system, because it's on cloud, actually is one kind of cyber system. And the machine tool itself is a physical object. So you see, this site A was conducted in Taiwan. Okay? So you see, in order to verify that the quality of the virtual metrology is about the same as the real metrology. So you see, the red dot is the real metrology value, and the black curve is the virtual metrology. So it's about the same. But at that time, the customer show the demos watch the demos in April 2015, and they like this one very much. So we just shipped to China, and we install the system to China. But China, you see, their machine, of course, is different from Taiwan. So you see, we have two different kind of. You see, this is the central. This is the current value. Okay. So you see, this just has 38 ampere, and this is 48 amperes. Amperes are different, so of course, the machine conditions are different. But we still use the same models built in Taiwan and to conjecture the value in mainland China. Of course, it won't be accurate for the very first one. So you see, the very first one we have red dot here. You see, the reliance index and global similarity index shows no good because we just detect that the modeling cannot cope with what we have in China for the very first one. So we will inform the physical object, try to do real measurement because we need to get this value for tuning the model so that this model can be rebuilt so that this model can take care of what we have in China. So you see, after rebuilding, after tuning this model into the virtual metrology systems, so you see, then we can check that. You see, the prediction and the actual value is about the same. So you see, after that, then we really can do the operations in real production line. So you see, after that, we just need to have 1 to 2 measurement only. All the others is just free run. And the value, I just said, this one is just the same as what we have. If you really try to bring it to the physical measurement, and the value will be the same. You see, we just check that the accuracy of them are correct. So actually, what we have, this operation is what we call cyber-physical interaction. Cyber system is the AVM, okay? And physical object is the machine. So cyber system detect that physical object has something wrong there. We need to recalibrate the model, right? So this is cyber-physical interaction. So then benefits of AVM, as you know that we can reduce, because we can reduce the purchase of metrology equipment, reduce cycle time, etc. So, and this is what I told you, the Industry 4.0, because Industry 4.0, they just emphasize productivity. They didn't mention about how to enhance the quality. But how I can do it, you see, because I know how to do total inspection, but Industry 4.0 didn't define that. So I just add AVM into Industry 4.0, becomes Industry 4.1. So this is, we can achieve the goal of zero defects. So you see, this is stage 1. So we can have stage 1 and stage 2 there because they just, said time is up. So I'm sorry, I don't have that much time to explain this in detail. But anyhow, just actually, this Industry 4.1 is in the paper of IEEE. So you see, applying Industry 4.0 together with AVM to achieve the goal of zero defects, the era of Industry 4.1 is taking place. So this is the selected papers and patents. Thank you. And because I don't have that much time left, actually, if you can allow me about 3 to 5 minutes, then I can show you that the, sorry. No. How to have mixed mixed wheel type continuous production result, the test result. And I show you really quick. When this has 3 types, okay? 61, 71 is 61A. So we just try to merge them and give you the idea, because in the afternoon I will demo it, how to have mixed wheel production, okay? So we just have baseline model here, okay? And of course we have 3 wheel types, then we need to have 3 models, okay? Then if we just shuffle them, I should say shuffle them in here, okay? And this is the shuffle result. We have 3 different types simultaneous. They just shuffle it, just randomly. And how we can take care of this one. So you see, we need to have a baseline model. And we just need 1 to 3 wheels to refresh the model. Then we can become 3 VM models for each particular wheels. So you see after that, and we can see is the very first one. Then use the first model, second one use the second model, etc. So this will be the result. And this is the combination. And we can sort in them into different categories. And the accuracy shows something like that. And let me show you what's going on here. And try to zoom it. And you see, this is what I saw. This is the combination. What you can see is something like that. But actually, we can sort in them with software into 3 categories. The first wheel type, something like that. The second and third. So you see. Then, because I don't have that much time to show you that, and in the afternoon, we will show you 2 different wheel types and have manufacturing together, and we will show you how this works. And this demo just have 3 different types. And then, I'm sorry. This is what we can see this afternoon. But anyhow, because they said time is up, I don't have that much time to show you. This demo will have something about 5 minutes. But anyhow, just give you the flavor that during the very first one, then he will use 1 to 2 wheel to tune the model. After tuning the model, and you see we have 3 types here. So after tuning the model, then you see the very first one being corrected in the first wheel type, and this is second and the third. So maybe just give me 30 seconds. Let me show you a little bit, okay? So you see, this one, this is that, okay? So another one. But you see, this one is here, okay? Another one. This another type is here. And previously, just try to refresh in the model. Okay? So, let me, because I don't want to occupy too much time from the others. So, anyhow, I'm sorry. Eventually, we will something like that. Okay. After, this is the combination. But we can sort them into 3 categories. And you will see this one in the afternoon. I'm sorry to occupy you so much time.